and share a video with you guys. Can you see it? Hello?
Yes, sir.
Yes, sir.
So here is the math actually. Give me a minute. I can open my pen actually. So, okay. So here is the math that we want to do today. I start with two vectors, d1 and d2 are given, and what should be the so sorry. So two vectors are given here. One is d1, that is 3i minus 2j plus 4k, and that one is d2, that is minus 5i plus 2j minus k. So these are the two vectors, and what we have to find is d1 plus d2 at dot d1 plus 4d2. So you can do it, right? Or you want me to do this kind of math, guys? Can you do it, or you want me to try one or two of the maths? Hello. Hello. You can hear me, right?
We can do it.
You can do it, right?
Yes,
because you just have to add them up in one, and in second case you have to take a dot product, a cross product between them, and then you have to make a dot product. So this is here is a math. Actually, these are the math that you have to do, and this is another math. Three vectors are given, A, B, and C, and you have to find A dot B cross C, A dot B plus C, A cross B plus C. This is also easy, right? So it's easy. Let me check whether we have any difficult math. Here is another math. Use the definition of a scalar product A dot B equal to AB cos theta, and the fact that A dot B equal to AX BX AY BY plus AZ BZ to calculate the angle between the two vectors. So actually they are asking us to find out the angle between these two vectors A and B. So and these things they are actually what they are using, they are just telling us the formula as well here. So what do you have to do? Same thing again, theta equal to cos inverse AX BX, this formula AY BY plus AZ BZ divided by AB. So this is the formula that we have to use to solve this math. And here is another math, problem number 34. Two vectors are represented by A and B. You have to find A cross B, A dot B, A plus B dot B, and the component of A along the direction of B. This is an easy math actually. So and basically these are the homework. This is the homework. So you have to do this homework. Okay, you have to do this homework. So and I already shared this lecture note with you guys, right? So I want you guys to try these maths at home. Okay, this is 6, 7, 11, 27, 30, 36, 37, 41, 42, and 42. So these are the homework for this chapter. So basically, we are going to start a new chapter today that is about one-dimensional motion. Okay, let's start our class. So let me stop the share and I start a new. Is it okay? Can you see the slide now? Hello.
Yes, sir.
Okay, so we're going to start with chapter 2 now. That is motion along a straight line. And a straight line, as the name suggests, the straight line means one dimension, right? So basically, this is also known as one-dimensional motion. A straight line in one-dimensional thing. So this is the second chapter that we are going to discuss today. So when at first we're going to start with the position, displacement, and velocity. These are the terms that are very closely related to the motion. And for one-dimensional motion, we are going to discuss what are the position, what are the displacement, and what is the average velocity. So at first, let's start with motion. What is motion? So in this chapter, basically, we're going to discuss the motion along a line or a straight line only. Motion is what? Can you tell me what does motion means? What is motion, by the way? If something is moving, then you can say, okay, it's in motion, right? Motion is really, and what is motion, by the way? Or we can say, okay, motion is just change in position. If an object changes its position with time, then we can say, okay, the object is in motion. And in this chapter, we are gonna concentrate only on the motion along a straight line. This straight line can be a vertical line or can be a horizontal or slanted line also. So, but this will be a straight line. And the second thing, is it clear? The straight line? The straight line is like this. Yes, straight, straight, straight. The object can move along this way or this way or this way. This kind of motion are one motion, one a straight line. Not this kind of motion, like the object is moving this way. This kind of motion is basically not a one-dimensional motion. This is not a one-dimensional motion. This can be like two-dimensional motion. Because in every case, the object, the motion can have two components or something like this. And second thing, how can we get motion? Or how can an object get a motion? An object starts moving when you apply some forces on it. By applying a motion, by applying a force on it, the object starts moving. This force can be pull or push, anything like this. Okay, and by applying force, you can change the state of motion as well. Once a object is moving, or you can stop it by applying force. Or if an object is moving by applying force, after application of force, the object can move faster. Or by application of force, the object can move slowly. This kind of thing. So object force is the reason that changes the state of motion of the object. So that's the second thing. And this moving object can be a particle or can be a big object. Okay, it can be anything. So these are the things basically we are going to discuss. So now at first we are going to start with position, displacement, and average velocity. So let's see, what is position and what is displacement? What is position and what is displacement? Actually, position is just can anyone tell me what does position means? Hello, my dear students. Can any of you tell me what does position means? Position is just a description where an object is staying at a particular time. At a particular time, the place where the object is staying is called its position. Like for example, let me say an object is moving along x direction. This is my x direction, let's say, and it is moving in x direction. This is my position 0. Let's say this is 1. This is 2, this is 3, right? This is basically from math, you know, this line of number, -1, -2, -3, right? And the object is moving along x direction. And if the object is here, let's say object is here initially. So what I can say about the position of the object? We can say, okay, the position of the object is at x equal to what? 3. Or say after some time the object is here. This should be x equal to -3, by the way. Position is x equal to -3. And after some time, let's say 3 seconds, the object is here. So the position now is x equal to +1. So position is nothing but the present state of the object. It tells us where the object is staying now. Okay, and then an object can move in positive direction, and also it can move along negative direction. Let's say here the object is moving from here to here. That is, the object is moving from negative to positive. That means we can say, okay, the object is moving along positive direction. And also the object can move from positive to negative direction. This is also possible, negative direction. Negative direction. Okay, so any kind of movement is possible. So now, as we know, what this position, and then there is a term that is related to position and relating to motion is called displacement. What is displacement, by the way? Let me start with displacement. What is displacement?
So I think displacement is motion in particular direction.
Displacement is motion in a particular direction, and how to define this mathematically? This is equal to the change in position. It's basically defined as the change in
Position.
change in position. And by the way, in a particular direction. I think it is better for me to take a new page. Actually, take a new page. So displacement is equal to change in position in a particular direction. Sorry, in a particular direction. Okay, so that means an object. This is position 0. This is -1. This is -2. Let's say this is +1. This is +2. An object starts from, and this is my x direction. So an object starts from here, from -2, and moving towards positive x direction, and reaches point 1. What should be the displacement? Displacement is the change in position. Change in position in a particular direction. That means change in direction towards positive x direction is this much. Here to here. And then how to calculate the displacement? This is basically displacement is equal to final position minus initial position. Initial position. That means, let's say the final position is x1, x2, and the initial position is x2. Initial position is sorry, my bad. Initial position is x1, and final position is x2. In that case, the displacement can be written as x2 minus x1. Okay, and the displacement is denoted by delta x. And by the way, tell me whether displacement is vector quantity or scalar quantity.
Sir, vector.
It should be a vector quantity because it is it has a particular direction involved in it. Okay, so this is the definition of displacement. And there is a related term. There is a related term, similar kind of term, that is called distance. Oftentimes we also use distance. What is the difference between distance and displacement?
A distance has no direction.
Distance is a vector quantity. Same thing, change in position, but this is a vector quantity, scalar quantity. Only change in position. Okay. So definition should be the same, but displacement involve a direction. That means we can say, okay, if it is like x2 minus x1, here is what? 1 minus -2. So your answer should be like 3 in positive x direction. Okay. And if I say the distance, what should be the distance between them? Same again, 1 minus -2, that is just 3. Okay. Let's say unit is meter or centimeter. It's 3 meter. So this is the difference between displacement and distance. And oftentimes we can use some graph to find out the distance between two objects. This figure is showing the position of an armadillo. Okay, the graph of xt for an armadillo that is stationary at x equal to -2, the value of, and then the other thing is oftentimes it is a easier approach to express the position or displacement using a graph paper. Oftentimes, we use graph paper to show the position or the velocity of an object. For example, this is the position versus time graph. This is the position versus time graph. Okay, and oftentimes we use position versus time graph to express the position of an object. Let's say this is the time axis and this is the position axis. Okay, and let's say there is a graph. Let's say 1, 2, 3, and then 4. 1, 2, 3, 4, 5. And if the graph is like this, what does this mean? And let me draw another graph like this. So what does the blue curve and red curve means, or what idea can you get from these two curves? One is red curve, another one is blue curve. What idea about the motion of the object you get from these two curves? Let's say this is the object 1 and red curve is for object 2. Can you tell me what idea you get from these two curves?
Sir, the blue one is
Sir.
changing position along with the time.
Actually, in case of particle 1, the position is changing. In 1 second it was 1, in 2 seconds its position was 2, at 3 seconds its position was 3, at 4 seconds its position was 4. That is, the position of the object is changing here. Okay, and but for part 2, what is going on here? The position was fixed at 3 seconds, 3 meters always. Its position was same at every time. That means the object is not moving. The object is not moving. Is it clear? Object is not moving.
Yes, sir.
Object, that means stationary. And this one is object moving. Let me draw another graph. Let's say two objects is moving. Okay, this is my x direction, this is my y direction, and this is particle 1. And this is particle 2. Sorry, it's not x, y. This is x and this is time. This is position and this is time. This is time. What you can tell about the motion of the object? For the two particles. Particle 1 is bolte paro. Can you tell me anything about the motion of the object? 1, 2, 3, 4, 5. Time is 1, 2, 3. Guys, can you help me? Please tell me what idea can you get from these two graphs? Now look at one thing. Let's say if I draw the position of an object by a straight line, this is 0 second, this is 1, 2, 3, 4, 5. So for the red line, if you consider the red line, what is going on here? With time, the position is increasing. That means the object is moving this way. Right? That means moving positive x direction. The object is moving towards positive x direction. Is it clear? And but for this one, for the black line, which way the object is moving? 5, 4, 3, 2, 1. That means the object is moving towards negative of x direction. The object is moving around negative x direction. Right? That means if a curve or if a position versus time is given to me, by looking at the curve, what you can say, we can infer whether the object is moving or whether the object is stationary. Stationary means in case of stationary motion, I will get just a straight a horizontal line. I'll get a horizontal line. But for a moving object, I will get a vertical or a slanting line like this. And also the direction of the slanting line or the slope of the slanting line will tell me whether the object is moving towards positive x direction or negative x direction. If the slope of this line is positive, that means the object is moving towards positive x direction. And if the slope of this line is negative, let's see, the slope is negative, that means the object is moving at negative x direction. Is it clear? Is it clear, guys?
Yes, sir.
Yes, sir.
And then that means the graph can tell me, give me lots of ideas. And now let's move further. A graph is given, drawn here. This is showing the same armadillo. It's average velocity and average speed graph. So, by the way, let me discuss that first. What does average velocity and average speed means? What is average velocity and what is average time? So, objects are usually changing their position with time. With time, their position is changed. Like I already brought a graph, something like this. This is the time and this is the position. This is the position versus time graph is like this. That means at time t equal to 1 second, the object was here. And at time t equal to, let's say, when the time is t1, when the time was t2, the object was here. And at t1, the object was here. And then in that case, the average velocity can be defined as the difference in position divided by the difference in time. So in short, the average velocity is equal to difference in position. That means this is my difference in position, that is, let's say, delta x, and this is my difference in time, that is delta t. It can be defined as difference in position divided by difference in time. Delta t is nothing but a difference t2 minus t1, and the position corresponding to t1, let's say it's x1, and the position corresponding to time x2. T2 is x2, so you can say x2 minus t x1. So this is the definition of average velocity. It is like, let's say you started from Uttara and you want to come to the like New Market, for example, from Uttara to Dhaka New Market, and when so you start from Uttara and then you want to come to like Gulistan, for example. So in your way, you cannot move at a constant speed, right? Because every time your position, your velocity of the or your speed is going to change. So average with speed will give you an average idea or average number at which the object is moving through the total path. So the total path change distance like that will give you the average speed. Now, this is the definition of average speed. Now, the thing is, let's say I wanna know the speed at a particular point. Let's say particular point here. What is the speed here? Let's say an object or you starts your most journey from Uttara to, and you wanna reach Gulistan. But I want to ask you, okay, what is your speed at Noakhali at a particular point, or what is your speed at Dhaka Airport, right, at a particular point? Or at a particular time, for example. So how to get this thing? That means I want to know the speed at a particular instant of time. What is that thing? So what is this thing? Instantaneous. That is called instantaneous speed. Instantaneous speed is the speed of an object at an instant, at particular instant. Okay. So like an object is traveling along this way. This is my time and this is my position. The object is moving this way. Okay. The speed is changing with time. Its position is changing with time, not constant. Okay. Somewhere the object is moving faster, then it becomes slow, then faster, slow, faster. This way the object is moving. And what I want to know the speed at this point, at a particular point or a particular instant of time. This speed is called instantaneous speed. Instantaneous speed or velocity is the velocity at a particular instant of time. That means I want to know the speed at this time. Whatever is velocity, or I know the velocity of the object at this time. So is it possible to know the velocity by using just only one time? Is it possible? Because velocity means what? Velocity means change in position Why change in time? So change in time means it involves at least two time, or change in position means it involves at least two position. But what I'm saying here, I want to know the velocity at this point, So how to get this thing? See, the difference, the definition of velocity involves x2 minus x1, t2 minus t1, or I can say delta x over delta t. And that means at least you need two time. So this two time difference can be like maybe 1 second, 2 seconds, 10 seconds, right? So when you want to know the instantaneous velocity, that means you want to make this time only one. How to get it? You can just make this difference in time very small, that is 0.00 second, 0.0001 second. So this much smaller difference, time difference, can be considered as a single time. So instantaneous velocity is basically defined as limit of what I have to do. I have to make the limit of this time difference between these two time as small as possible. That is tends to 0 or close to 0. And delta x over delta t. Do you guys have the idea of limit? Do you know what this limit means, guys? Hello. Hello.
Sir, it's something that is tends to 0.
Yeah, you studied this thing, right? Yeah, in last semester.
Yes, sir.
In math. Okay. So delta t means this time difference is making 0. I have to make this time difference 0. That means let's just have a look here. Here the time difference between t1 minus t2 was like very long. So what I have to do, I have to squeeze this time difference so that this t1 and this t2 comes to very closer to this point. Let's say I want to know the instantaneous speed at this point. So I have to make this difference very small. If I make this time difference, let's say it was like 5 milliseconds. But if we make t1 equal to, let's say my t1 was like 1 second and t2 is like 5 seconds. Okay. But I want to know the instantaneous speed at 3 seconds. So difference it is not possible to put 3 here. It's t2 minus t1. So what I can do, I can make t1 as like 3 point or 2.9999999999, and t2 is equal to 3.0000001. In that case, see the difference is what? 0.00000. But that means this is small. In that case, your this point become, or the time difference occur actually at here, very smaller time difference. Okay, like this. So in that case, you can get the like instantaneous speed, and it is defined as dx over dt. Now we can ask me a question. Okay, sir. So how to make this time difference so tiny? How to make this time difference so tiny? কিভাবে এই time difference আমি tiny করব? How? Do you have any idea? Yes. So the thing is, what I'm saying is like the instantaneous speed or instantaneous velocity the instantaneous is defined as limit of delta t tends to 0, delta x over del t, that is equal to dx over dt. So this is the definition basically. This is the definition. Differentiation of x with respect to time. Now my question is, how I can make this delta t so small, or like if a curve is given here, that is the position versus time graph, and this is the speed of an object, and someone is asking me to find out the instantaneous speed at this time. Okay, let's say this is t1. So how to make delta t small and get the instantaneous speed at this point? Do you have any idea?
স্যার একটা নির্দিষ্ট পয়েন্টে বা একটা নির্দিষ্ট টাইমের মধ্যে তো ভেলোসিটি বের করা যায় না, তো খুবই ছোট একটা জায়গার মধ্যে t2 মাইনাস t1 করে লিমিট ইউজ করতে হবে বা ডিফারেন্সিয়েট করতে হবে।
That's the thing that I already mentioned that you have to do. So, but then how to get this thing from this graph? So dx by dt, what does this mean? What does dx over dt means? Dx over dt is nothing but the slope of the x versus t graph.
Yes, sir.
So that means what I have to do, if someone is asking me to find out the instantaneous speed at this point, তোমরা শুনতে পাচ্ছ না? Guys, can you hear me? Hello?
Yes,
Hello?
sir. Yes, sir. শোনা যাচ্ছে, sir.
Okay. So what I'm saying is that instantaneous velocity is defined as dx over dt, and dx over dt is what? It is the slope of the x versus t graph. So if a graph is given to you, if someone is giving you a graph and asking you to find out the instantaneous speed at a particular point of time, what do you have to do? You just have to take the slope of the, you just have to calculate the slope at that particular point. Is it clear? That means if you take the slope at a particular point, that will give you the instantaneous speed at that point. For example, I want to know the speed here, instantaneous speed here. What I have to do, I just have to take the slope here. Any place. Okay, so that's the idea. That is the basic idea. Okay, or one thing you can also do here is that, like, so this is how we can find out the instantaneous velocity. Is it clear? Can you hear me, guys?
Yes,
Can you
sir.
hear me? Okay.
Sir.
Let's see. Yeah.
Yes, sir.
Yes. Okay. Thank you. So and there is a similar idea. Likewise, velocity and this velocity. There was a related term that is called speed. Speed is what? Speed is nothing but velocity. The only difference between speed and velocity is what?
Sir, speed কোনো direction
Speed
নাই.
is scalar. Speed is scalar, and velocity is vector quantity. So, so the definition for instantaneous velocity or the and instantaneous speed would be the same thing.
Right.
Same. Okay, because speed is scalar, velocity is vector. So basically, they are the same thing. So just velocity. The main difference is that velocity involves a direction. That's it. Yes. And here a graph is showing here. This graph is showing that on object, the position of an object, how the position of an object is changing with time. From here, you can see if you take the slope, here, this is a straight line. Look here, from between 3 seconds to 8 seconds, the slope, this is a straight line, and the slope of a straight line is what? A straight line has a constant slope. So here you can see here the slope is plotted here in the bottom graph, in the bottom one. So this is how the position is changing, and this is how the slope is changing, or that means this is how the velocity is changing. You see here. So the portion where the position is straighter, that means here the slope is constant. That means the particle is moving at a constant speed. So if a graph, position versus time graph, is given to you such that it is like a straight line, just by looking at the graph, what you can say? A straight line has a constant slope, and the slope of position versus time graph is constant. That means this object is traveling at a constant speed. Object is moving at constant speed. Is it clear?
Yes, sir.
Okay. And then acceleration. What does acceleration means? If you if an object is moving with time like this, this is position versus time graph. So here the object is moving faster, and then it becomes slower or something like this. That means its velocity is changing. See here, the slope is changing with time here, right? The slope is changing for this curve. That means the velocity of the object is also changing. So you can also plot the velocity as a function of time like this here. This showing how the velocity is changing with time. See here. So the velocity also can change with time. It's not like that the velocity should be constant always. So velocity can change with time. So the rate at which the velocity is changing or is called the acceleration. And there exists two kinds of acceleration. One is called average acceleration. Average acceleration is the difference in is defined as the ratio of change in velocity to the change in time. For example, let's say two time. One is t1 and the time is t2. And the velocity at time t1 is v1 and the velocity at time t2 is v2. Okay. So in that case, the average velocity between t1 to t2 is defined as v2 minus v1 over t2 minus t1. This is defined as the average velocity. Average velocity is the average of velocity over a certain period of time. Same as the average speed or average velocity. And we have another term that we are going to use more and more, that is called instantaneous acceleration. Same again, instantaneous acceleration. Instantaneous is defined as the velocity at a particular instant. Velocity at a particular instant. And velocity at a particular instant means we have to make the time limit as 0. That is, limit of delta tends to 0, delta v over delta t. And this is equal to dv by dt. This is equal to dv over dt. Okay. So instantaneous speed, and oftentimes we are going to define a is by a only. So instantaneous speed is defined as dv over dt. And by the way, v is defined as how? V equal to dx over dt. So acceleration can be written as d square x over dt square. So we have to differentiate position twice with respect to time. Then we are going to get acceleration. Is it clear? And the other thing is acceleration, and instantaneous acceleration means dv over dt. That means if I have a velocity versus time graph, just by plotting or just by taking the slope at a particular time, I can get the instantaneous acceleration or acceleration. So to get the acceleration, what I have to do? I just have to get the or take the slope or gradient of the acceleration position, velocity versus time graph, and this will give us the instantaneous acceleration or simply acceleration. Is it clear, guys? I think these are all known to you guys. Okay, so let's try a math now. Let's try a math now. A sample problem, acceleration and time. A particle's position along x-axis is given here. Okay, and it is given by an equation x equal to 4 minus 2070 plus t s cube. Okay, the position is given by x equal to 4 minus 27t plus t cube. The question is, because the position is depending on time, find the particle's velocity and acceleration from this curve. A curve is given, an equation is given, which is showing that the position is how the position is changing with time. And from this curve or from this equation, you have to find out the velocity. How to get the velocity? How can I get the velocity? Velocity is defined as what? Tell me, please. Velocity is defined as dx over dt. Velocity is defined as dx over dt. That means the dt of 4 minus 2070 plus t cube. So this is basically equal to minus 27 plus 3t squared. Is it okay? Is it clear to you guys?
Yes, sir.
I think you all are familiar with the differentiation stuff, right? And same again, we have to find out the acceleration as well. Acceleration as well. So acceleration is nothing but dv over dt. Acceleration is dv over dt, which is basically ddt of minus 27 plus 3t squared. And this is basically equal to 60. So this is the acceleration. Is it clear? Yeah. And
Yes,
then this was part A actually. This was part A, and in part B, it was asking that is there ever a time when v is equal to 0? whether the velocity was 0 at any instant of time, or in other
Yes,
words,
sir.
it is asking when the velocity was 0. At
When
what
the
time?
body is not moving, time is
Yes,
equal
when
to
the
0.
body, at what time? At what time the object was not moving? That means we have to find out the time when the velocity was 0. So that means v equal to 0. And v means basically minus 27 plus 3t square. That means 3t square equal to 27, or t square equal to 9, or t equal to 3. So that means, yes, at time t equal to 3 seconds, the particle was not moving, or the velocity was constant. Is clear? Sorry, the PowerPoint is closed. Can you see the slide?
Yes, sir.
So okay. So that's that. So let me write it once again. So that means v equal to 0, that is equal to minus 27 plus minus 27 plus t square, 3t square by the way. So that means t equal to 9, t equal to 3. So at t equal to 3 seconds, the velocity was 0. Save it. And so, and the thing is, the velocity of an object can be constant as well, or likewise, the acceleration of an object can be constant. So, if an object is moving at a constant, moving such that the acceleration is constant with time, if the acceleration of an object is constant with time, in that case, what we can do, we can derive several equations for the motion of an object. Where that means when an object is moving at a constant acceleration, that case we can derive several equations for the motion of the object. And I think all these equations are familiar to you guys. Can you see it here? V equal to V naught plus AT, x minus x naught equal to V naught t plus 1 of AT square, something like this. I think all of you are familiar with these equations, right? You all know this equation. So here, V equal to V naught plus AT. V naught plus AT means final velocity equal to initial velocity plus acceleration versus time. Displacement equal to V naught t plus half AT square. V square equal to V naught square plus 1 of x square. Or we can write this as this way: V equal to V naught plus AT. Is equal to oftentimes we also use V or U. We oftentimes use G and U. U is the initial speed and V is the final speed. V equal to U plus AT. S equal to UT plus 1 half AT square, right? S is the displacement, and V square, final velocity square, equal to U square plus 2AS. Okay. So these are the formula basically for the motion of an object when it is moving at a constant, when it has a constant acceleration in it. So in our next class, today I'm going to finish the class here. From our next class, what we'll be doing, we're going to use these formulas to solve the maths. So there are a number of maths. Tomorrow we are going to solve, or we're going to try some mathematical problem, solve some mathematical problem using these formulas. Is it okay? So do you guys have any questions? Hello?
No, sir, no question.
Okay, so let's stop here for today. So that's all for today.